factored. Okay? And what I mean by that is some of you went through the problem I saw in the weekly quiz and said, if I gave you, like, well, I'm just use an example, I gave you this, and I said solve. X squared minus 5x plus 4 equals 0. And I asked you to solve. Okay? And a lot of you went through and said, okay, I can do that. You teed it up. And you got x minus 4, x minus 1 equals 0. Teed it up. And you stopped. That's not solving. That's backward. Solving means get the answer that makes sense in the problem. And when there's no word problem, it means all answers. So like on here, what makes this 0? What minus 4? Positive 4. And what makes this 0? Positive 1. So those are my two answers. That's solving. Setting those parentheses equal to 0. I don't say equal to 0 right there, but it's like taking, I'm just going to go down here, it's taking x minus 4 equal to 0 and x minus 1 equal to 0 and get my answer. We're forgetting that step. One thing I noticed as we go through. The other thing I noticed looking at a few things this weekend, to be honest, I didn't look at anything until like Sunday, yesterday, so. But the other thing I looked at was this. Let's give you a problem of x squared minus 4x plus 2 equals 0. And it doesn't factor. It doesn't factor. I don't even know if I have one. You got one? Okay. It doesn't factor. It doesn't factor. So what do we do? It doesn't factor. But what does it do when it can't factor? What method we have to solve that equation? Quadratic formula. And what troubled me a little bit this weekend is I said, I said, I'm going to use the quadratic formula. And first of all, I saw a lot of people using that for the quadratic formula. That's not the quadratic formula. That's the discriminant. Then I saw a lot of people going like this. And I thought, that's not the quadratic formula. I saw a lot of people doing that one. That's not the quadratic. Because that first term is not squared. A lot of people were putting a square right here. Negative b plus or minus the square root of b squared minus 4ac over 2a. Not b squared. And then I see a lot of different things to do here. Going through here, first of all, I see people plugging in the values. I saw some good stuff. I saw people over the side writing down what your a was. A is 1. B is a negative 4, C is 2, you know. A couple other things I saw was people, if it was an equation without equal to 0, people forgot to get it equal to 0. Okay. That was one thing. And going into this problem, they said, okay, negative B. People said, well, negative B is already negative, so I'll just put a 4 there, right? No, we have to use that negative, still part of the problem, so it's a negative 4. Plus or minus b squared minus 4ac over 2a. Plugging in my numbers. Make sure we plug in our numbers accordingly. I don't change signs. I just put them all in parentheses. Put them all in parentheses. So two negatives make a positive. So I get 4 plus or minus the square root of negative 4 squared. 16, okay? So we got 16 minus 4 times 1 times 2. 8 over 2. Now remember, there underneath that square root, it's a minus sign. A lot of people say, oh, it's 16 times the negative 8. No, it's 16 minus 8. So we're going to have 4 plus or minus the square root of 8 over 2. Now square root of 8, I don't know off the top of my head what the number is. Plus or minus square root of 8. You can go to your calculator, it's like 2.8, 2.9, something like that. I'm going to guess. I'm going to say 2.8. I don't know exactly. It has to be 2.8. Okay? Now what I do with my answers, a lot of people did differently. First of all, I have 4 plus this divided by 2. What's 4 plus 2.8? 6.8. Divided by 2, and I heard somebody say 3.4. That's one of my answers. Then the other one is 4 minus 2.8. 1.2 divided by 2, which is 0.6. 3.4 and 1.6 and 1.2. So that's quadratic formula. We need to know this formula. We need to know this formula. That's 2 things I know. Anything else you want me to cover? I know Caitlin had your hand up. What was the question?
When you're graphing, you have to find out if it's quadratic or exponential or linear or whatever. How do you put it in an equation?
I think we're going to everybody need a calculator. We're going to do these. Just take your card out and get your calculator. Make it so we'll call it the I don't know if I have enough. I didn't even check. There. Okay, so let's look at number 13 on page 563. 13 on page 563. Now there's other ways to do these problems. You know, honestly, there has to be other ways. When
I don't know where it is.
okay, gonna get through it today. There's other ways of doing this stuff. Remember back in the old days, I call it the old days, we didn't have calculators like this. We didn't. You know, we did everything by hand. To be honest, we didn't remember it back then. I don't remember doing it all the time. I don't remember that. So they think back to remember everything in college. I don't remember all that in college. And my niece asked me this weekend, she's in a statistics class, which will start pretty soon here. And she asked me 4 questions in statistics. 5 questions in statistics, and I think I answered 2. I couldn't remember the other one. That was like college beginning level statistics. I don't remember all the rules. That's a lot of rules. So, but what we're going to do is the easy thing. And so I'm going to look at problem number 13. I think I said right. And part C says estimate the common difference, or part D, write the equation of the model. We're going to get exact. We're going to write the equation first, okay? So what I want you to do is go to your calculator, and I want you to go to table like I did. My calculator is dead. My calculator is dead, I'll get you 4 back. Okay, everybody has the calculator on the table? If you just go home and then click table, you're fine, you should be fine there too, or new document, either one. So if you want to, you can just click home, new document, no, and then just go to list and spreadsheets, same thing. Sorry, list and spreadsheets, set table. Now I want you to arrow up and label your first column X. And then my arrow over, once you hit that, tab over, and arrow the second column Y, and then you have your two columns named. It's list and spreadsheets, so you're gonna label your first column X, label your second column Y, and make sure it's in there. And then I want you to just put in that first list. You see that list for problem number 13, I think it goes like 0, 1, 2, 3, 4, or something like that. 0, 1, 2, 3, 4, right? That goes in my first list and the numbers in my second list. So we're doing number 13. I think I got the right values here. I got 1, 2, 3, 4. And the second list I have is 58, 123, 187, 251. Okay, everybody got that in there? Now, did anybody ever, if you went through this problem, you probably could find out pretty closely, you know, we did some of the techniques in class on video to tell if what numbers work, right? If it's a linear or quadratic or exponential, right? If you look at this one goes up like 65, 64, 64, so it's about 64, right? So what kind of model is this? It goes up the same adding each time. If you remember the video, if it goes up the same each time, it's a linear model, right? So we know we're going to look at linear on here. So let's go underneath here. Go under menu. We're going to go menu. Go statistics. We are kind of doing statistics here. And statistic calculations. And we're going to do linear regression. Now there's two linear regressions. There's mx plus b and there's a plus bx. Mx plus b. That's your algebra one. A plus bx is more statistics. So we're going to do the mx plus b. Okay, what do we label the first list? X. So we're going to put x in there. What do we label the second list? Y. Y. And then we're going to click OK. Okay, everybody get there? Now, if we look at this, you know, doing it on the calculator is going to get a little easier than doing it on a piece of paper or doing it by hand. We're going to have the exact answer here. You'll notice right here it says regression equation. If I arrow down one here, it'll put it in here mx plus b. Isn't that our equation, right? What's our m? What's our b? -6. So really my equation for this one is, if I went back here, I got y equals mx plus b equals y is equal to 64.3, I think it was, right? X plus a -6. There's my equation. That's the equation that best fits that data. That has the least amount of error. Yes? Variable numbers. Okay, did everybody get that? Now I want you to notice one thing on your calculator. Let's say I didn't see the pattern. Which model is best? We did 3 models in this section, didn't we? We did linear, we did quadratic, and we did exponential. Okay. Okay. So now if I went back to menu, statistics, I'm gonna do. You don't have to watch. You don't have to do these real quick. I'm just gonna do quadratic real quick. X, Y. Okay, and then I'm going to do statistics and exponential regression, right? Exponential, X, Y. So I got my 3 equations. So A times B to the X, right? AX squared plus BX plus C. And the thing I want you to notice here is this. Okay? Here's my exponential. Notice that value. 0.9551, right? That's the R squared value, right? Now I'm gonna go over here again. Oop, quadratic. Quadratic will work too, but, here's my linear. 0.999985, right? And here's my quadratic, 0.99998. Okay? Really, which model is the best for this set of points? Quadratic. We use the linear because we were thinking of the 64 being different, but which model is best? How do we know which model is best? The closest the R squared value is to 1. Whatever one has the R squared closest to 1 is the best model. So, what R squared is, for a better definition, what it means is this. This is getting into heavy statistics here. For a better definition is this. There's in statistics, there's two types of variation. Variation, for easier term, means error, okay? There's two types of error. There's explained error and there's unexplained error. Now think about which one you want more of. You want more of explained error because if you can explain it, that's good then, right? If it's unexplained error, that means you don't know why it happened, right? What R squared stands for is how much explained error there is. What percent of explained error there is. So if you look at the quadratic, which percent is explained? A very high percent, right? 99.9998%, right? How much unexplained is there? Very little. That's why it's that's what R squared stands for, is the explained error, percentage of explained error. That's you don't have to understand, don't have to know that definition or anything, but that's just the mathematical term behind it. That's where it comes from. Does that make sense? How does that make the question? So let's look at another one real quick. Let's change the numbers. Now what's nice here is that I got this on my calculator, right? You got X and Y there, right? So let's look at number 23. Okay. Now I'm not starting over. I'm not going to start over. What 23 says what? Use linear, exponential, quadratic to find an exponential model. The greatest value R squared indicates the best model. Okay, so 23. I already had it set up. I have linear, quadratic, and exponential here already, right? So what I'm just going to do is arrow over and arrow up. Here's my values, correct? I'm not going to start over. I'm just going to change my values. It automatically changes my equation for me. I don't have to do all the work. So if you look at my linear equation over here, I'm going to put 23 and I have a -1. I'm 0. You'll notice my values are changing right there. 1, 2, and 3. And I know that. And then I'm going to go up here, change my y values. 4.6, 3.5, 2.4, 1.3, oops, 2.4, 6. So I typed in my values. I didn't do any more work. I already had my equations up here, right? If I look at my linear regression up here, is it a good model? How close is it to 1? It is 1. It's a very good model, isn't it? Now, if I looked at my quadratic regression, is it a good model? Now, I'll come back to that in a second. If I look at my exponential regression, is it a good model? What's my R squared on my exponential? 0.84, correct? Which model is best? Now you look at here, linear and quadratic are the same, okay? Now let's type these in. I want you to look at this. Linear model goes like this. I hope you remember this. Quadratic model goes like this. correct? Those are the 2 models we're dealing with. Am I agree? Look at your linear model if you have it in front of you. What's my M on your linear model on your calculator? Do you have it? Check your value. What's your M? Negative 1.1? Okay. So y equals to negative 1.1 x plus, and what's my b? I didn't hear it.
3.5.
3.5? Okay. Now over here, how am I quadratic? Anybody do the quadratic? Anybody? Did you get values?
For A, I got
Okay, so that's 0, x squared. B you got
negative
x plus c is, and they say that's my quadratic model. What's 0 times x squared? 0. So it's the same. So which model do you think is better? It really is a linear model because it's not a quadratic equation if it doesn't have an x squared term in it, right? So really, sometimes your calculator will say both models are 1, but is this a true quadratic equation? No, it's a linear equation because it has 0 for my a. So these two would be just a linear equation would be the best model. So don't be tricked in that and say, oh, they're both the same. If your a is 0, they're not both the same. You don't have a quadratic equation. Any other questions for me? Did I help get those down a little bit? Okay, I got a question for you. Use a lot of people. No, never answer that. It's speak up. Can't hear. Flew back on Thursday. Takes about a week for my ears to go back. My ears never pop on a plane. So it takes about a week before I hear anything. So you have to speak up and get a question. But I have a question for you. Let's say I have a square pool. Okay? And the side of my pool is X. Can I add a 1-foot sidewalk around the whole thing? Once I add that 1-foot sidewalk, the area of the sidewalk included together is 900. What is the dimensions of the original pool? Okay. Is it impossible?
Yeah.
What do you do? One thing that confused a lot of people is this. The key word in this problem is a square pool. All sides are same. So if one side is x, all sides are x. So if I said it's a square pool, watching that keyword there, square, I have this. X by x. Right? What did I tell you happened? 1 foot or 1 meter sidewalk around the whole pool. 1, 1, 1. Around the whole pool. Correct? Now I'm going to draw my picture. Here's my new picture. If I add 1 all the ways around, what does this side become? X plus 2. What does this side become? Agree? Is I adding 2 both sides? Okay, now. Area of the pool and sidewalk together is 900. So how do you make area square? Times what? Okay. So if I take this times this, I'll make it easier. This times this. Could I go like this and say that's that? X plus 2 times x plus 2 is x plus 2 squared, right? Now why I did that is equal to 900. Now, some people did it. Some people can do this different ways. People can FOIL it out, get everything on one side so it equals 0. Another way of doing this is, I'm trying to get x by itself. Square root of both sides. I can take the square root of both sides. So I'm going to get x plus 2 equals plus or minus. Get that question a lot on yesterday's weekend quiz. That question, why is this wrong? There's two answers. Remember, plus and minus. Now what? Subtract 2. So that x is equal to and minus 2 on this side. I got 30 minus 2 is, and negative 30 minus 2 is a negative 32. Now, what does x stand for? Can't have negatives, so it stands for the side length of my pool. So negative is not going to work. So my original dimensions of my pool are 28 by 28.
Is there anything wrong with, I just did 900, the square root of 900 is 30 equals the whole, the side lengths, and then subtract 2, and it's 1 foot wide, and I got 28.
Oh. It works to square, but it won't work. And I guess a lot of times I want to do is set up an equation. The problem is, and that's why when we get to ones that are harder to work, then it's hard to set up the equation if you're not used to it. So, now how would I find the dimensions, the area of my pool? What am I? Dimensions are the same, but what's my area? Multiply what? Like I would, so 28 by 28. So if I found my area of my pool, I'm going to go 28 by 28, and that's going to give me whatever that is. 784? So meters squared or whatever it is. So that's area of my pool. Now, anything else with it? I'm trying to think of anything else that people have solved. I'll go over any questions. We still have about 10 minutes or so.
What do you do on 25?
25.
You just
Make a
sum
table of
numbers
points using
or-
It asks you to make a table of values. Okay, so I can write down my equations here. My equations here are x squared minus 3. Right? What's my second equation?
3x squared.
And my third equation?
4x squared minus 5x.
4x squared minus 5x. Okay. So it asks me a equation. I'm just going to put it on here. I'm just going to make some values here. Let's just say 0, 1, 2, 3, 4.
And then you just have to plug in.
Plug them in and get my table of values. You know, so if I start with 0, these are pretty easy here. At my 0 value, I'm going to have a negative 3. I'm going to have a 0, and I'm going to have a 0. I'm just plugging in 0 into the equation.
We already know
That's for part A, make a table of values. For then plug in 1, I got 1 minus 3 is negative 2, and then plugging in 1 here is 3, and plugging in 1 here is negative 1. I'll plug it in 1. I'm making my table as I go here. 2 would be 1, 12, 16 minus 10 is 6, 3 is 6, 27, now let's get harder, 21, right? Is that right? 36 minus 15 is 21, okay, and then for 13, 48, 44. So there's a table of values, that's part A, I think. It just says make a table of values. Find a comment, 5 points. I guess I didn't do 5, I did 4. I guess I did 5 points, 5 points. Make a table of 5 points using consecutive x values for each function. Find the common second difference. Second difference means go up 2 levels. So from here to here, it's +1. From here to here, it's +3. From here to here, it's +5. And from here to here, it's +7. I agree. Now, if second level means go one more level, I got +2, +2, +2. So you kind of see that one, right? All the same. Now, if I went here, I got +3, 9, 15, and 21, right? Now go to the second level there, I'm going to get 6, 6, 6. Okay, second level, 2 layers up. This one's a little different here, which is a -1, +7, unless I plugged it in wrong. 15 and 23, is that right? And this would be 8, 8, 8. So my second level. 2 layers up. Right? Follow me? Just find the difference between those 2 values. And so that's part A.
That part B.
Part B is what is the part A says find the second level, find the common second difference. Now it says what is the relationship between the common second difference and the coefficient of x squared? What'd you say? It's always double. If you look at it here, the number in front of x squared is 1 here. That number is 2, correct? The common difference here is 3. It's going to be 6. Here is 4. It's going to be 8. It's always double whatever my A term is going through. And so it's always twice that. Part C. Explain how you could use this relationship to help you model data if a function were not given. Whatever you get for the common level, second level, is always going to be twice what the A term is, right? So if I knew my common second difference was 16, what's my A term? 8. It's always going to be half of what that number is. So you could always use that to figure out your quadratic A term. Could you use it to figure out your quadratic equation? No. You have to do a little more work, but to start it, you could use that. There's one little hover sections here, so other ones. So my question to you want the test tomorrow?
No.
Yeah, you can. How much question?
Yes.
We didn't get a packet last week.
You did a packet last week. So I think that's online. You turn it off online. It's on your schedule. If we don't have a test tomorrow, I hope you bring questions. I don't want to stand here and look at you guys saying you have questions, you have questions, you have questions. Okay? I want you to bring your questions. We can move to online. I think somebody asked. I think I moved the online back to Wednesday, the 30th. So I'll be there.
Wait, that's also like Friday.
I don't remember what I put up there. So. Whatever. So, I don't think that's kind of like whatever. I'm going to give you a chance. I think some of these questions that some of you did over the weekend, if you want to go back and fix them and show me all the work, I'll give you full credit back. Some of you won't be questions say, I don't understand that. Give you a chance to go back and look at it. Here's a hint. Somebody take pictures of your homework too. Okay? If you're going to take a picture, take it so I can read it. Some of you are taking pictures like this far away on homework on the ground. It's like, I can't read that far away on the picture. So I wrote some response to that, you can't read. So So take it, so when you're looking at the picture, when you're done taking it, if you can read the work, I can read. But if I can't, if you can't read, assume I can. I wanna see your work, I wanna see your answers, but I can't read it for something else. So. Anything else? Hopefully you bring me some questions for tomorrow.
Yeah.
Fine.